Cool, thanks for having me. In case a bunch of people are still in the room next door, can I get like a big cheer, like, whoa, this is the best thing in the world, just so they all come in? Go on. Cool, yeah, thank you so much. That'll get them. Cool. So yeah, thanks for the introduction. I'm Ada Cannon. I'm a developer advocate for the web browser Samsung Internet. Before I which is like a web browser, it's a fork of Chrome, which is maintained by Samsung. Our priorities tend towards like privacy, security. We've built an ad blocking, tracking blocking, that kind of thing. Also a bunch of power user level customization, so you can change anything about the browser to make it work for you, which is kind of cool. But before I literally just mentioned it, who here had heard of Samsung Internet? Oh yeah, this is good. Cool. Of those 4 people, who tests their websites on Samsung Internet? Oh, amazing. See, I love this audience because it's huge impact, because no one's heard of it. So yeah, Samsung Internet, it's a pretty good browser. They pay me to say that, but I do also use it because I think it's good. We do have 5% of all mobile web traffic, and we are a Chromium fork. We're not just a wrapper on Chrome. And we do occasionally make mistakes when we pull in changes from upstream. And so things may break occasionally. So please, please, please test your websites on Samsung Internet and let us know if they are broken, because that's important. Anyway, that's the bit I'm paid for. Now for the fun stuff. So yeah, I'm a developer I'm a web advocate for the browser, but the other role I have is I am co-chair of the W3C Immersive Web Groups. So these are the groups responsible for designing the APIs related to dealing with augmented reality and virtual reality in the web. The work is done totally in the open on GitHub. You can read the issues, pull requests, and even find the minutes of previous meetings. For those who are really interested in today's topic, I really recommend reading through some of the specs in this repo. Each spec should contain 2 documents, so a very low-level spec designed for browser engineers to help them implement it. But the other document is an explainer document, which is human readable. I mean, not that browser engineers aren't human, but it's more friendly. It's got in-depth descriptions of how and why the API works to give you a good, deep understanding. So if you really are curious about the in-depth detail, I recommend checking that out, because I have a lot of content today and I'm not going to go super deep into anything. So the API for dealing with virtual reality and augmented reality in the web is called Webxr. The X in XR is kind of like a placeholder for augmented reality, virtual reality, mixed reality, that kind of thing. Webxr is, if you want to do AR and VR in the web, Webxr is a good API to use for that. There are a few things you can do which are hacks built on top of WebRTC, but I'm not going to talk about those. So the main body of the work I do is the Webxr API. It's designed to access the sensors and displays of the immersive hardware. So using the sensor information from the hardware, you know where the user is, what they're looking at, what they're holding and where it is, and you can render a virtual world from the user's point of view. And you do that using WebGL or WebGPU, or WebGL2. You send that to the device of the screen at the frame rate of the device, and it gives the illusion of that the user is in a virtual space. The core API is Webxr, but it's got a lot of modules around it. And the idea is, with this modular architecture, is that it's based around progressive enhancement. So you tell the session before you start the various optional features and the required features for your scene, so that when it loads up, It can be like, yes, I have all the required features, so we can actually start, and I have some of the optional features, so you can use them when they're available. The kind of hardware it supports, so the core of the API was virtual reality headsets. So this is called the immersive VR render mode. It's for devices with opaque displays, so you can't see the world around you. And it was the thing we started working on first. A bit later, we started supporting augmented and mixed reality headsets. So the AR headsets of today tend to have two different formats. So the kind you've probably seen around is the more fancy, expensive holographic type. So devices like the HoloLens, or the HoloLens 2, or the Magic Leap. So these devices are a bit more expensive, and they work by projecting the 3D scene onto the glass in front of the user's face. So they see the real world, but they see the 3D content laid on top of it. The other type of device is pretty much in all respects very similar to a VR headset, except it has color cameras around the headset, so it displays the real-world content on the screens that it's also using for displaying the 3D content. You can also use these kinds of devices, toggle them into just doing VR or doing mixed reality mode. But yeah, for all intents and purposes, though, from a developer standpoint, they're exactly the same. You don't need to be aware of anything in particular. But probably the most common AR device you will find today is a smartphone. Sorry, it's not iPhones yet. Safari doesn't yet support the Webxr APIs. But Webxr is designed so that not only do you have to not be aware of whether it's an opaque or transparent display, you also shouldn't need to be aware of if the user's using a smartphone or if they're using a headset. They're designed to be built so that if you build something that works well on the phone, it will also work well on a headset. And that's been a large part of the effort to make sure there is a good route from where we are today to the kinds of devices we'll see in the future. If you want to try it out on your Android phone, I'll have some links later in the talk you can try. You'll probably need to have Google Play services for augmented reality installed, Google Play services for AR. Not all devices work, but if you have a Samsung Galaxy S device from the recent few years, that should work. But yeah, if you can get any AR content working on your phone, then Webxr should work. So this is what the Web and XR stack kind of looks like from the bottom up. So firstly, at the bottom, we have the raw hardware on the device. This is usually a set of cameras of some kind, or some kind of special depth sensor. The access to this information is usually not available to developers, even on native platforms. Next, there is the native XR API that's built on top of it. So this is probably something like AR Core or OpenXR. These often take the raw sensor information, they combine it with some machine learning to reveal as much information about the environment as they can to the developers. And Webxr is then built on top of these APIs. So many of the features we expose through Webxr are the subset of the features defined by the majority of the APIs. This just makes it slightly easier for us to spec. So often we find the common path through all of them and spec along those directions. But we often tweak it a little, or the information might be fuzzed, or the accuracy might be reduced in order to protect users' privacy. Because we really have to balance giving XR developers the really powerful XR APIs they expect, but we have to balance it against the security and privacy users should expect from the web. You don't want someone using a simple scene where they put hats on their friends, but then find out that it's recording all of their faces and sending it up to a database. So we've got to balance that kind of thing. But as APIs go, Webxr is pretty well designed, in my opinion. I mean, I work on it, so I'm a little bit biased, but yeah, I like it. I do recommend developers use the API natively. But there is the other side of it. It is directly tied to WebGL and WebGPU, and those aren't developer-friendly. They are nightmare APIs that require like 300 lines of code just to render a simple cube. And so you kind of have to use a library for the WebGL part. And since Webxr is pretty friendly, those libraries often just include Webxr support with it. So if you're just getting started with building 3D stuff, you might not even touch Webxr directly. You might just need to know what features are available so you know they're there for you to use them. There are even some further abstraction libraries which are built on top of the JavaScript libraries. There's one I rather enjoy called A-Frame. It's a web component wrapper. So it's built on top of 3JS. So you control 3JS's JavaScript API through HTML, which is kind of cool. I'm going to talk more about A-Frame later, because I'm going to give you some real code samples. So hopefully by the end of this talk, you feel confident enough to go ahead and build your own augmented reality thing. I'm going to run through now some of the features Webxr provides. You don't super need to know the names of the modules and how they're divided up, but it's useful to know that they're there, that each one has, in order to use it, you need to say that this is an optional feature or a required feature or such. So this is the list of modules I'll be talking about in this talk. This is not an exhaustive list. There's a lot more features. Well, there's a few more features which are available now, but they're more virtual reality focused, so I'm not going to talk about them. And there's a few more which are, well, there's hopefully many more coming down the line. Because there's more, as XR hardware gets more and more advanced, we're going to keep building modules so you can use the new features in the XR hardware. So the first module I'm going to talk about is designed to help developers build experiences which closely match the user's real hardware. So the Webxr Gamepad API, it exposes a gamepad object on the XR input source. So that an XR input source is basically like a VR controller. This isn't a VR controller, this is a slide remote, but you get the idea. So on the input source, there will be a gamepad object exposed on it. And if you've used the web's existing gamepad API, like the navigator.gamepad, it will look very, very similar. It's basically the same API, which we stole. But we don't actually expose this special XR gamepad on the normal navigator gamepad list, just to prevent confusion. But even though we did steal the gamepad API for use in our own API, the gamepad API isn't very good. It doesn't give you a lot of detail about the controller. You just get a list of buttons and a list of axes, and it tells you if they're what the value of the button is. So not super useful. What does button 0 or button 1 mean in the real world? And what you want to know is the A button or the X button or the trigger. But to work around this, we design two things. So we have a standard mapping we encourage hardware vendors to use for their controllers. So even if you just say button 0 is probably this and button 1 is probably that, you're probably actually going to be correct. But the other thing we did is we have an open source library with explicit JSON descriptions from the manufacturers for the mapping of every single controller to its gamepad location. And what we also include in there is 3D models of every single controller, which is very cool, also from the manufacturer. So if you just want, even if you take nothing away from this and you want some free 3D models of XR controllers, yeah, they're all in our GitHub repository. And they're all the official models as well. So what the developer can do is take in this information. So with the gamepad object from the controller, it can work out what the controller is from the profiles information, also on the XR input, compare it to the information from the JSON library, the Webxr input profiles library, and work out what the controller is, what it looks like and how it behaves, and also animate all of the individual buttons and things on it, so when the user uses it, the thing they see in their hand in virtual reality moves as well. It's very cool. This is actually, it's kind of complex to build, and there's an implementation in 3JS, so you don't need to worry about it. But I thought it was pretty neat, so I wanted to show you. So next we have hand input. Hand input lets you do hand tracking. It's in the name. So a lot of hardware does various ways, some with computer vision, some with special sensors. It works out what the user's hands look like and lets you see it in virtual reality. So it gives you the position, location of every single joint in the hand, but it doesn't do gesture detection. So you know what the user's hand looks like, but you can't tell if they're pinching or pointing or making a fist. If you want to do that, you have to work it out yourself. Sorry. But it looks cool. Like, this is in virtual reality, obviously. And you can see what the user's hands are doing, and it's really fun and feels really good to build real hand interactions. This isn't the web, like it's cool stuff. Right, now on to the actual nitty-gritty of the subject. Augmented reality, what I'm here to talk to you about today. So the augmented reality module is one of the simpler ones in the Webxr repo. All it does is add an immersive AR session type, so to replace immersive VR, and no other AR features. All it lets you do is place 3D models over the user's environment, which isn't a great experience. It's not particularly useful, but the other modules build on this to give you a really good effect. So most importantly, hit testing and anchors. So this is the module that actually lets you sense the user's environment. So you can find a point in the real world using the hit test API. So you point your phone and then the user taps it, or if they've got a controller, they can point their controller and click. It then fires a ray out of their controller or out of the user's finger, like a virtual ray. And where it hits the real world, it tells you where that point is in your current 3D space and the angle it is. So users can place objects on the floor or walls or the ceiling or wherever they want. There's another module which kind of goes along with it called anchors. And what anchors does is if you create an anchor from a hit test, it will keep track of that anchor over time. So during the session, you could place some 3D objects, walk out the door and go into a different room, and then come back, and your objects should remain where you place them. It's a really powerful API that gives you a really nice effect. And this is what it looks like. So now the actual objects are placed in my environment. They stay where I left them, even as I move around. It's a really good effect. But they still feel like they're just a 3D object that's not really integrated with the environment. And that's where lighting estimation comes in. So lighting estimation, it tells you the color, 15 or 5? 15, cool, good. So yeah, it tells you the light direction and the color. So you can cast shadows, you know where to place the highlights on the model. Essentially, you just place your directional light wherever the API tells you. It gives you a reflection map of the user's environment. So you can make a reflective object in augmented reality reflect real objects in the user's environment, which is just amazingly cool. And it even gives you like an approximation of the global environment lighting. So it's not just like one bright light source, you actually get a really nice, realistic effect. Should have picked a better image though, because I took this photo really early in the morning when there's super bright sunlight coming inside from my room and everything looks a little blown out. It does work really well though, and I suppose I've been like sat around this conference all day, I could have made a better screenshot. But in non-extreme lighting situations, it does look really good. But you'll notice that I'm also casting a shadow on the floor. And so casting a shadow really makes it feel anchored into the room. And so when you have this combination of like virtual objects casting, casting virtual shadows on real objects and receiving reflections from real objects, it's just a really great effect. And finally, I want to talk about DOM overlay. This is like the last module I want to cover. So this is a really important one because it's currently the only way to use HTML and CSS with Webxr, because it's an entirely like graphics-based API. And it's a simple API. You pick an element and it's now stretched over the full screen of the Webxr content. Unfortunately, it's only available on smartphones because that's where it makes sense. The idea of stretching something full screen over an immersive display where you have full view of the environment is kind of a nonsensical sentence. It doesn't make any sense. So right now, this is only a phone-based API. But it looks cool. You can use HTML and CSS to build nice interfaces. So the title and the button on this page is accessible. You can copy and, like I've selected the text at the top of the thing. So you can copy and paste the text. You can use it with a screen reader. Like everything you can do with the normal web, you can do with the DOM overlay. So it's like a massive win for accessibility. And a great way to build interfaces without having to resort to the complexity of rebuilding them in WebGL, especially when HTML and CSS are super powerful and they're already right there. All right, so I think I've got about 10 minutes left, so let's actually get to building something. So I've said a few times that Webxr relies on WebGL to work, and you can't use HTML and CSS. And so you need to use a framework. Fortunately, there are many to choose from. So these are just 6 of some of the more like popular, well-known ones. And they all have Webxr built, all of these have Webxr built into them. For Unity, you have to download a plugin to export. The one I'm going to talk about today is A-Frame. But there are libraries that are usable at all levels, no matter what your coding experience is. So some of them are totally no code. You just drag and drop objects and then you export it and it just works. Some are declarative, like A-Frame. Some are imperatively coded with JavaScript or React. Like React 3 Fiber is really popular and actually quite fantastic. And if you want to get really deep into the nitty-gritty, then using a lower level one like 3JS or Babylon is totally worthwhile. But there's a lot of these, and I'm only going to go into one. So like I help maintain a website. Like as you can tell from the screenshot, like I'm thoroughly a developer. There's not a designer bone in my body. But what it does have is getting started instructions for all of the popular WebGL, Webxr libraries, so that you can get started building something in an environment you're familiar with. But I'm going to talk about A-Frame. A-Frame is like a custom HTML wrapper around 3JS. So you write simple HTML, and you get virtual reality and augmented reality capable WebGL code that just works. And even though I've been doing graphic stuff for years and years and years, I still use A-Frame in my day-to-day life. Even though it looks simple, it's really good to use. It has good abstractions, and it removes a lot of the boilerplate. And you can even build your own components based on 3JS. So if you do start leveling up your graphic skills, you can still dive into the nitty-gritty and do some really powerful things. The main advantage for me right now is that I can fit the code on a single slide. So that's what I need. And here it is. This is the boilerplate code for A-Frame. This is copy and pasted from the documentation on their website, which is really good, I should say, like if you want to get started. So we have a scene, which is where you put all like the global configuration. And then we have a few custom HTML objects, so like a sphere, a cylinder, a plane to go on the ground. All of the units are in meters, because that actually matters in Webxr. Things have real physical size. So anything you do in Webxr, the unit will tend to be meters. The angular unit is often radians, although in A-frame it's degrees to make it more friendly to people, because that's what people are more familiar with. The axes, so like X is across the screen, Y is up and down the screen, and Z is coming out of the screen towards you. So if you want to place something in front of the user, you place it in the negative Z axis. Anyway, here's what that looks like. And this is all ready to go for virtual reality and augmented reality. But if you were to load it up in augmented reality, you wouldn't actually see anything. You'd just see the scene in front of you, because the sky component is actually in the way. So the first thing we need to do is hide the elements we don't want to see in augmented reality. And A-frame has a component for that. It's called hide on enter AR. And if we attach it to the sky, it hides the environment. But now we're at the position we were in before, where we just have augmented reality, but we don't have any real-world understandings. They're just floating in the air. But what's quite surprising is that these objects are actually meters big. So the radius on this sphere is set to 1.25. So this is a 2.5 meter tall sphere, which is bigger than my apartment. So we also need to shrink them down and make them user scale, which is another thing that's important to think about when dealing with augmented reality. You have to fit the objects into the user's environment. So to do that, we're just going to wrap them in an object called myObject, and then we're going to shrink it to 1/5 its original size, like 0.2, 0.2, 0.2. To get it to be placed in the real world, we use the AR hit test component on the A scene in A-frame. We'd say that its target is this object we just created and put our objects in, so that when we tap on the screen, it now places that object wherever we tapped. And what's kind of neat about the AR hit test component is that it also uses the anchors API under the hood. So we still get that really powerful tracking behavior. Next, we're going to match the virtual lighting to the lighting in our environment, just as we showed you earlier. So to do that, we use the reflection component. This automatically generates the reflection maps. And in augmented reality, it does the lighting estimation to get the reflection maps. It also handles the lighting as well. So if we add a directional light, it will take control of it, and it will display it too. And this is a really powerful ability for realism. I can't state more thoroughly just how powerful the lighting estimation API is. And finally, DOM overlay. We want to add some simple interface for the user to do stuff. So adding the DOM overlay is a two-part process. So we create the element we want to use. In this case, I made a section element and put some stuff in it. And then you tell Webxr that on the A-frame scene, under Webxr, you set its overlay element to have the query selector for the element we just created, the HTML element. Then that HTML element gets stretched over the whole screen. And you'll notice here that I have a few buttons and radio buttons in here. And there is one thing that's a bit awkward. So whenever you tap on the screen, it fires a select event in Webxr. But right now, we're using the select event to place the 3D objects. So when the user tries to tap on any of the buttons, it kind of makes the objects jump around, and it looks terrible. And if you want to do with AR stuff with DOM overlay, you would definitely hit this, but this isn't widely known. And so there is a before XR select event, and you listen for that on the DOM overlay, and if you cancel it, the event won't be passed to the layer underneath. And it's just I put it in the slides, so if you do this stuff, you could read through my slides later. This will save you 4 hours of time, because that's how long it took me to fix this. And I have the editors there to ask questions to, so yeah, very useful. But I'm going to sort of go off topic slightly. What about headsets? So I mentioned before that DOM overlay is the only way to display HTML and CSS in XR. And that's weird, right? Like Webxr is a web API that's basically throwing away a big part of the web platform. Like, I'm chair of the group and I think it's weird. But this is like, it's a problem we've been trying to solve for like 5 years now. It's really tricky. If you want to find out why it's such a hard problem, come find me afterwards and I'll tell you all about it. I can tell you about all the failed attempts we had and all what the blockers are. There are some like hacky alternatives you can do, like mostly involving the canvas element. Like you can just copy big chunks of the HTML into like an SVG foreign object, and then including like the CSS files and stuff like that, and then you can render those to a canvas and then put that canvas on a WebGL texture. Like it's bad. There's the approach taken by 3JS, which kind of like redraws the DOM elements using canvas commands like rectangles and circles and text. It's a bit better. It's not a perfect representation, but it kind of works. Like you could also try rebuilding the whole interface in WebGL, but then you're basically doubling your workload, like one in HTML and one interface in WebGL. Like there's not a good solution here. I wish there was like a happy ending. Like I think we've got like a good solution coming down the pipeline, but I've said that like 3 times in the past, and each time I've been wrong because it just didn't work out in the end. Hopefully, like, 3rd time's the charm, but we'll see. Anyway, back to the topic at hand. So if you want to interact with 3D objects, so like you've got the DOM, you can interact with that, but you want to tap on the objects. The traditional way of doing it in WebGL, that if you look at Stack Overflow will tell you, will actually have some surprises. Like it will, and you can make that method work with Webxr. Like there's a few hacks you can do to get it to work, but it'll only work on smartphones. Like it'll work today, but you probably shouldn't use it. And it may seem weird, like me telling you there's a way that works today on today's devices that you shouldn't use. But the web scale is larger. Like web scale requires long-term thinking, building things that won't decay, and you build a healthier web. So XR on the web today looks like this. Tomorrow it's probably going to look like this. This is real hardware you can buy today, but it's not popular amongst consumers. But probably over the next few years, these kinds of devices will become more widely available. But Webxr in the future, like, I don't know. It could look like anything. Like, there are companies out there right now working on holograms, like 3D holographic displays, like the Iron Man type. There's another company that's working on like putting the display inside a contact lens. So yeah, if you want to interact with an object in XR, once the XR session is started, you want to listen for the select events. And then you want to use the information you get from the select event to work out the location of the user's finger in 3D at that point in time, and use that to populate a raycaster. And you fire a ray from the user's finger, and then you work out the 3D object is touching. And that will work on phones, it will work in headsets, it will work everywhere. So this is like a lot of stuff I've just covered. But I've made an example. You can view the source code, it's all done. You can try it out now, the demo works. You can remix it, it's good. If you're building stuff, this is the Webxr emulator on Chrome is really useful. It has some AR support, but it's still early days there yet. But the VR support should be enough for testing what it's approximately like in an AR headset. But thank you so much. I've been Ada Rose Cannon from Samsung Internet, and you've been a great audience.
Do we have any questions for Ada? Yes.
Hello, thank you for the presentation. I would like to ask you, where are the data of anchors are stored, actually?
The data for what?
For anchors.
Oh, anchors. Where's it stored?
I mean, can we scan an area with using the Samsung Internet
Like,
place and just put some anchor somewhere? And where are these data?
Yeah, you can place like a few anchors and then you keep track of them over time because like you have a list of them and then each frame you can get where they are. Like you can't place too many. You probably don't want to be placing like tens of them. You probably also can't do like 3D scanning of a room or anything like that. Like we've purposefully limited the API to stop people scanning, getting 3D scans of people's environment whilst they do things.
So it's just they're temporarily used just for this area and that's it.
Yeah.
They are not
So
stored.
and they're just used whilst right now they're just used whilst the page is open. So you close the page or refresh,
And
they
that's
all
it.
get cleared.
Okay.
We are looking at having persistent anchors so that you can have the anchors placed and then close it or refresh and then come back a few days and open the web page and they'll still be there. But we haven't spec'd that out yet. Those discussions have only just started happening.
Okay. Thank you.
One more question here. Let me give you the microphone so we can all hear the question.
Couldn't you use the internal storage of the browser just to make it a long-term, for example, and whenever you don't clear the browser, you can actually store some anchored spots there?
You can't serialize the anchors into like a format that's restorable. But also you could theoretically save the 3D location, but there's no guarantee when you start back up that the user will be standing in the exact same position because the 000 point is the place the user was standing when they started the session. So if the next day they started it, I'm now away from the mic, pretend I'm stood over there. If they started it from over there, then the entire scene would be offset and the objects you're trying to restore would also be placed across
So
the
if
bed.
you actually open the application whenever you're standing somewhere, the moment that you open the application, this is the 0 point that you're standing on. So
Yes.
whenever you pinpoint something, an anchor, something in the application, and you move, it actually relates to that, to the 0 point that you were before.
Yeah.
But in case you actually do use a GPS device to actually store where the 0 point is,
Unfortunately, even that's a bit odd because the AR system might make mistakes when measuring a room. So if one day it measures your room as like 1.8 meters and the next it thinks it's 2 meters big, then everything is going to be slightly offset and skewed. And so everything we do in Webxr is all done according to a reference space in a session.
which is also done during the initialization of the application.
Yeah, so it makes doing stuff like this really tricky. Also doing stuff like, if you have two users and you want them to see the same 3D object in the same place, that's also really difficult because
With
we don't
two different
support,
devices, you mean?
because it's different devices, they started in different places, and we don't do marker tracking, so there's no, like they can't both have a common like reference space that they can both relate to. So it makes doing stuff like it makes persisting stuff and sharing augmented reality content very difficult. So persistent anchors which we're talking about like in this group right now, will take us a little bit of the way there. And I'm hoping in the future we'll have probably marker tracking. And in the distant future, we'll probably have shared anchors so that you could send an anchor to someone else. But unfortunately, the entire native side of the industry is still, all that area is totally up in the air. There's no shared formats that we can use in the web. So it makes it impossible to spec, which is frustrating.
Thanks, that's great.
All right, I don't think we have any more questions. So thank you so much, Ada, for that very interesting talk.